Hey, welcome to the lab. I'm Steve. Did a previous video on a DOCSIS 3.1 cable modem, initially coming online in a 5 SCQAM and 1 OFDMA block scenario. So this is a quick follow-up on a measurement of the channel gap or space or the adjacent channel measurement, block in this case the lower SCQAM. So just to recap for what's on screen in front of us, we have a Rotor Source FSW analyzer. The analyzer is not only a spectrum analyzer, but it's also a vector spectrum analyzer. So there's a VSA function in here. And at the moment we're in a real-time view of the upstream spectrum. So let's have a look at the frequency range on that. So we have a start frequency on screen here of 15 megahertz and a stop frequency of 70 megahertz. 5.5 megahertz per division across the screen, and in this particular upstream setup, 5 SCQAMs, upstream 0, upstream 1, upstream 2, upstream 3, upstream 4, and then an additional OFDMA block here, which is 10 megahertz wide. Modem's already online, so down here we've got the CLI terminal, CMTS. So let's just have a quick look at that. Show cable modem. Fortunately, commands come off the bottom of the screen, but hopefully you can see that. Yep, so one modem online, 1825 by 6 mode operational. There's its IP address. So that particular modem is bonding to 25 downstreams, which includes 1 OFDMA channel. And 6 upstreams, which is these guys we can see on the real-time analyzer up here. If let's have a look at it. What's its IP address? 10.50.215. We can have a quick look at that modem noise. So there you go. So the OFDMA channel is currently CNSR 42 dB. SCQAM is averaging around 40 dB. You can see at the moment there's no uncorrectable code words, and error rates looks really good. There's some pre-corrected code words happening on the OFDMA block, but essentially it all looks pretty good. Just bear in mind that this modem is not running any traffic at the moment, so these counters would have been from a previous test or even the last video I've just done. At this minute in time, this modem is just doing regular station maintenance, so it's just random bits and ones and noughts in the QAM, and occasionally also you do the same in the OFDMA block. I've lightened the view on the analyzer to make it better for the video, but in some ways, let me just go back to that display. In some ways, the dark view actually looks better when looking at the SCQAM. So there you go. You can see some subcarriers becoming active in the block. There you go. A minute. Mesmerising, eh? Anyway, on this side of the screen, we've got byte blower, Adjacent byte blower. This is just to load up the this particular modem with traffic. In fact, I could load up any of the 7 modems along the CMTS, but probably won't use that for this particular video. Down on the bottom here is just a list of commands that I can copy and paste into the CLI when needed. Not really going to bother too much with those at the moment. Anyway, the first subcarrier for the block is configured to be 52.925 megahertz. It's actually configured to be 52.9 exactly on the CLI. And the center frequency of the lower adjacent SCQAM is 49.6 megahertz. What we'll do is we'll measure the gap between the two. So to do this, and to make our life a little bit easier, I'm going to actually trigger some traffic. it's actually going to try and run 200 megabits off the upstream, but kind of doesn't really matter to material for what we're doing at the moment. This is just an RF measurement that we're going to take. So right now you can see the OFDMA is loaded, and so the SCQAMs, and you can see the loading time as well from the waterfall diagram. Go back to CLI and have a look at the modem there now. So yeah, we can see that the correctables accounting for the OFDMA block. So LDPCO is doing its work and mopping up what it needs to mop up. But in terms of uncorrectables, yeah, everything's nice and clean. And we've got 42 SNR, so the MER will be good as well. And hopefully, I'm not going to go and look for this, but hopefully we'll be running 1K CRAM in that block. So what I'm going to do is switch to a, so that's a real-time view on the FSW. I'm going to switch to a spectrum analyzer. This one here is currently not active. But this basically is what is it? Let's have a look. So it's got start frequency 47 and the stop frequency 56 So essentially, this spectrum analyzer is only going to look in detail at this very narrow portion here between the SDQAM and the OFDMA block. Literally where the gap is, and that means we can do some precise measurements on it. So as we're running traffic, what we'll do is we'll start that analyzer running. Give that a second. I've actually got a maximum hold trace turned on here as well, but because I've lowered the resolution bandwidth, obviously that has a means the measurement is really, really precise, but obviously it slows things down considerably. Right, so might as well leave that when I'm talking. So, for reference, that this block here, or this signal here, is the lower SCQAM to the OFDMA block. Marker 1 is the center frequency of that, so as I said previously, 49.6 MHz. Don't worry too much about the levels at the moment. The analyzer is running off a test point on the optical receiver of the test network we've got, so the levels are kind of material for what we're doing right now. Really, really interesting at the moment in the width of this gap and what's going on here. So marker 1 being the center frequency of the SCQAM. Delta 2, which is delta to marker 1, 2.56 megahertz above, is essentially pretty damn close to the 3 dB down point of that SCQAM. So think of that as where the symbol rate stops or the data stops, 3 dB delta. The actual end of the block, if you did the calculation for based on 6.4 megahertz for this channel, so 3.2 up and 3.2 down, would be where vertical line 2 is. So vertical line 2 there, 52.8 megahertz would be the end of that SCQAM if you added the 3.2 onto the center frequency. On the right hand side, we have the OFDMA channel, or the start of the OFDMA channel. Can't get my words out. We have subcarriers. You can actually, at this resolution, you can actually see the individual subcarriers. There is a marker sitting in there, marker 3, 54 megahertz. I can drag that around. Let's pop it on one of the subcarriers. There you go. 53.685 megahertz. And I'm sure if we did the calculations on where the subcarriers fall in this block, that would actually be a valid subcarrier. But interesting that you can see them all there. But again, the marker's just there for reference purposes. It's only really, for what we're doing at the moment, it's only really just an indication that the block knows the block and the block is there. The level is kind of immaterial, as I say, because it's set correctly on the CMTS, but the analyzer is working on the test point. So anyway, vertical line 2 is the first subcarrier in the block. So as I said previously on the real-time view, this block is configured with a start frequency of 52.9 megahertz, and that makes the first active subcarrier 52.925 So yeah, that's the gap basically. You can see between that frequency 52.95 and V2 52.8, about 100 kilohertz roughly in there, sitting in there. If you measure that down to the end of the usable data they're in, let's take vertical line 2 down to delta 2. Set that correctly. It's approximately there, 52.16 versus 52.925 megahertz. So that would be the gap down to the usual data. But yeah, essentially with the 3.2 bandwidth, that would be a 100 kilohertz spacing down there. You can still see the two running into each other, so SCQAM will disappear off down here for the roll off, and the roll off of the subcarriers for the OFDMA block again is disappearing off down here and disappearing underneath the SCQAM. The reality in terms of data, yeah, so we're running data right now. So a quick look at the, it's been running a while. Let's come back to the CLI and we'll have a quick look at those counters again. So give a modem noise. So you can see for that particular SCQAM, still running 40 dB SNR. The number of error code words has increased dramatically while we've been talking, and you can still see that we're running completely error free. Correctables there at all, so yeah, this SCQAM with this level of noise, clean network, as I said, it's really happy with the English channel spacing. The block, the OFDMA block, averaging 41.9 dB there, and again you can see the good code words has massively increased. LDPC still mopping up, correcting errors, and the uncorrectables is still seen at 0. Anyway, that'll do for now. What we'll do next is I'm going to make a quick modification of the IUCs that we're using. The variable bit loading IUCs, that is, so I'm actually going to take those out of the config, but I will leave the free standard IUCs in there that we've got configured. So IUC 13, 64 QAM, 12 at 256, and 11 at 1K QAM. I'll leave those in there, and then what we'll do is we'll add an impairment to the block. At the moment, I've got a real simple impairment. We'll add that to the block, and then we'll